Hey guys, recently on YouTube I saw this. It's magnetic propulsion in SpaceFlight Simulator. My first thought was that this has to be fake. And watching the video, you can see that the person is using no gravity and no drag. So I thought those were two variables that could easily cause something that you put on the launch pad to float up. And then when I did my own tests, I saw that this actually worked. But I was wondering, could it actually be a form of propulsion to deorbit or to raise a satellite's orbit? And so that's what we're going to find out in today's video, because I've built my own magnetic propelled spacecraft and we're going to test it out. We're going to raise, lower, and even try to deorbit a satellite using magnetic propulsion. Let's get started. You can see our spacecraft is in space. Now, I launched it into a 357.6 by 48.4 kilometer orbit. I did it in a highly elliptical orbit because I wanted to make the change that the magnet makes to the spacecraft's trajectory quite apparent. So, first of all, let's break down how this works. We have a magnet inside the middle of the spacecraft. Now, what are the magnets? Well, the magnets are the docking adapters. The docking adapters seem to have some kind of magnetic field which causes them to accelerate towards one another when they get close together. As a result, when we implement this into a spacecraft, when we jettison this magnet, it'll move down the shaft. And at the end of the shaft, you see, I have a solar panel. The solar panel will be used to bounce the magnet back to the docking adapter, which will cause the magnet to accelerate towards it, thus moving the whole spacecraft forward. This creates momentum, therefore it is indeed a form of propulsion. So when you saw the YouTube video that I showed earlier, when they demonstrate magnetic propulsion works. Now I'm going to demonstrate it on a spacecraft. First, let's undock the magnet. You can see that the magnet is floating backwards. Now I'm going to extend the solar array, causing it to come back towards the docking adapter. And now you can see that the magnet is coming towards it. And when we did this, our entire orbit seemed to change by about 0.1 or 0.2 kilometers. Now I'm going to try to raise our perigee. The magnet now floats back to the end of the shaft, or then I'll use the solar panel to cause it to come back towards the probe. As you can see, this process is quite slow, but you can see our perigee is actually rising. This proves that magnetic propulsion is in fact a form of propulsion. Now, I'm going to deorbit this spacecraft because, well, I figured it's cool and it would also demonstrate the capabilities of magnetic propulsion. we don't really seem to be making as big as the difference in our perigee or in our velocity as we were. This is probably due to the fact that we are getting closer to Earth, and that as you get closer to a planet, your velocity increases because the planet has more mass, therefore it pulls you closer to it, and as you get closer to it, you accelerate. So the little velocity that we gain from doing this magnet trick doesn't seem to be working as we're getting super close to the planet. So I'm going to time warp to our apogee, and when we get to our apogee, we should actually see a much larger difference in our orbit when we do the magnetic propulsion, because of the fact that when you reach the top or the apogee of your orbit, that is when you're going the most slow, because of the fact that you're the farthest away from whatever celestial body that you're orbiting. So now we're orientated. Let's fire off. And now you can see our periapsis continues to decrease. So let's think about how long it took for us to get to the point where we're going to be hitting the atmosphere of SpaceFlight Simulator. Well, it's taken us so far 1.5 orbits, because right now we're about halfway through our second orbit. So 1.5 orbits and about 40 minutes of just sitting around doing the same thing over and over and over again. This is why I don't think magnetic propulsion is super ideal, nor was I very believable in that it did actually work, but it does. So let's continue. 20 minutes and we're still doing this? No, I mean, not since we started. Since we started, it's been like, I don't know, probably like almost an hour since we've been doing this. It's gonna take a long time. We're almost 100 kilometers. So it's taken us 243 kilometers, I don't know, like 20 or 40 minutes of just doing this to get our periapsis down from 30 to 14 kilometers. So it's taken 40 minutes for our periapsis to go from 30 kilometers to go from 30 kilometers down to about a little bit more than half. So that just gives you an idea of how inefficient this is. And once again, you guys are super lucky because you don't have to sit here for a million days doing this like I do, because I'm, through the magic of YouTube and editing, I've sped up time so that you guys don't have to have such a boring experience as I'm having right now. as we're falling through the atmosphere, we're going to take a look at our map. On our map, you can see our original trajectory, and now you can see our trajectory right now. So you can see the substantial difference that magnetic propulsion does due to your trajectory over the span of about 5 million hours and a million days, and just the course of you having no life. So I'm good. It looks like we're gonna deorbit. Looks like we're gonna land. I'm turning RCS on. I'm not cheating. I'm just doing this because maybe we can get the spacecraft to survive. Just maybe, if we can get it to with the ion edges down first. Let's turn these things on. Maybe they can slow us down. Most likely not. That's not how it works. Chances are the probe will survive because of all the, because of the fact that we have two probes, one's on the inside, one's on the outside. The outside's going to act as outer shell, protecting it. The inside is just, the outside is going to get destroyed. The inside is going to be safe because, because the outside's going to act as a shell, protecting it. We're coming in at quite a high velocity, but of course this is deorbiting spacecraft, and if SpaceFlight Simulator did re-entry effects, then this spacecraft would already be long gone. Let's see if we can land this thing. It looks like we might actually be able to land this thing. I should have attached parachutes on this. God, this thing is like an achievement all on its own. But yeah, actually looks like we might land this thing. Also, the balancing on this isn't too bad. It's probably going to flip around in a few seconds. Yeah, actually it's pretty good. I'm going to start using RCS to try to slow ourselves down. Alright, just passing down through 3,200 meters. Going at 71 meters per second. Looks like we might actually land in one piece. We're probably going to land around maybe 20 or 30 kilometers, so definitely if the spacecraft remains this orientation, the probes will survive. Alright, now passing down through 2,000 kilometers, 53 meters per second. Imagine landing on Mars using this kind of propulsion. Actually, you could do this propulsion to land on Venus. You just gotta have a lot of parachutes. Alright. Never mind, we might not be coming down at 20 meters per second as I projected. Engines fire. Okay, let's try to get this thing down to 20 meters per second. Come on, 30. Nope, we're not going to get 20. 100 meters, 30 meters per second, 50, 40, 20. And we have landed. Now that we have finished deorbiting and we have demonstrated that magnetic propulsion works, what are my thoughts on it? Well, as I've already said many times, this form of propulsion is not efficient at all. Because of the fact that this form of propulsion really relies heavily on Newton's laws of physics, as does normal rocket propulsion. But with this one, due to the small amount of acceleration you get from this, you really don't get that good of an efficiency, such as when you detach the magnet that causes your spacecraft to move in the opposite direction, therefore getting you only a 30% amount of the kilometers or meters per second that you want to get. Such as when I wanted to get, like 20 kilometers and I would detach it, and it would make it 20.1, and then when it would bounce back, it would make it 19, because of the fact that pushing it off and then bouncing it back really isn't that efficient. However, if you were to do this without the solar panel pushing it back, the efficiency would be even worse. It would be probably something like 40% efficiency, where this method would only work 40% of the times you bounce it, or you try to get it back, because of the fact that the solar panel pushing the magnet back helps add to the momentum that we want to get. So there's two variables we demonstrated in today's video. The first one is magnetic propulsion. The second one is we demonstrated propulsion using the laws of physics. When we use the solar panel to push the magnet back, the solar panel also pushed the entire spacecraft forward. This, once again, as I said, is due to the laws of physics. So, in conclusion, would I recommend you trying this out? Yes, if you really want to, but no if you want to have an efficient, fast, and not very space-consuming method of propulsion. Because of the fact that in SpaceFlight Simulator you can't make tiny parts, at least in 1.35 you can't, but you know, in 1.4 I'm sure you can by BP editing and all that stuff, but in SpaceFlight Simulator I don't recommend doing magnetic propulsion because of the fact that it takes up so much space and you have no room if you want to put people or some kind of instrument on the spacecraft. So that just about wraps up today's video on magnetic propulsion. If you would like to have more videos of me talking about this kind of stuff, leave a like, subscribe, hit that bell to know when the next video is coming out, and I'll see you guys later. Have a good night.